The diagram below shows the blocks of mass. Mass equals 2 kilograms on the frictionless horizontal surface as seen from above. The three forces of magnitude, force 1 is 4 newtons, force 2 is 6 newtons, force 3 is 8 newtons, are applied in the blocks. Initially, the rest of the surface are at the angle shown in the diagram. In this problem, you will determine the resultant force of vertex from a combination of 3 individual forces of vertex. All angles should be measured counterclockwise from the positive x-axis. All angles are positive. This is our graph. To calculate the total resultant force, F ratio of force 1 plus force 2 plus force 3 acts on the mass, and this will be the formula we're going to use later on, which I'm going to show you on how you do this. So we already know the force that they give us because they already listed right here, the 3 magnitude force. So we're going to put it down. Force 1 is 4, force 2 is 6, force 3 is 8. So we put that down here. Now the problem is we found the force. However, we need to find out that's applying in the graph. So we are going to find the x and the y force. To find the force of x, we're going to use force, all the 3 forces applying cosine times theta. And to do that, we're going to apply all the force. So force 4 cosine times 25 theta. Because remember, the theta represents the degrees of every other force. So like 25 is force 1, force 2 will be 325 degrees, and force 3 will be 180 since that's like it's in the side. So we're going to do that. So force 1 for cosine of 20 times 25 theta will be 3.625 newtons. So nope, that's the same thing. So 625 newtons. And then force 2 would be the same thing, but different theta, which would be 325. So 6 cosine 325 will equal ourselves to 4.915 newtons. 915 newtons. And then for this one, for force 3 is represent the last one. And we already know that force 3 is for the cosine would be located as a negative. So it would be negative I, and negative I represents the x. So keep that in mind because we're going to use that in our formula. So there we go. This will give us ourselves negative 8 newtons. So there we go. Now we combine all the newtons that we found on all 3 forces, which is the same thing right here. This is applied for force x and force y. We'll get ourselves 0.54 newtons. Now for Fy is force, all force times sine of theta. So there we go. So force 4, say sine times 25 will equal up 1.990 newtons. The other one will be 6 sines times 325. This will equal sub negative 3.442 newtons, and then 8 sine times 180 J times equal to 0 newtons. We plug the M all together to find Y, and we'll get ourselves 1.752 newtons. Now we use the equation right here. This represents the I and the J. So what we need to do now is put them all together into the equations, like square root of 0.54 square plus 1.752 square. And this will equal to 1.83 newtons. And this is our final one. What angle does the Fx make in the positive x-axis? Keyword is angle. And since to find the angle, we use h tangent. Since that's representing the positive, because it's representing the whole entire thing. But we're going counterclockwise, so keep that in mind. So h tangent times fx, force x, and force y, or force y, force x, my bad. So we use the total amount of newtons that we found already to plug into our resultant formula. So h tangent 1.752 over 0.54. This will equal to 72.86. 72.86. We're not done here yet. Since this counterclockwise represents the 360 degree, because they have to go 360, we subtract it. So 360 subtract 72.86. This will equal to 290. Remember that we need to round it to our final answer. Initially it would be 287, but we round to 7 to the 8, which would be 90. What's the magnitude of the acceleration vertex A? Since we're looking for acceleration, we use the formula of force radians over mass. And to find that, we will use 1.83, which is the force radians, divided by the mass, which would be 2 kilograms. So do that. We'll get ourselves 0.92. Remember to round the 7 to the 1, round the third digit number. This will be 0.92 mass over second square. Now, this is 290, but there's a reason why, because what's the direction of the acceleration? In other words, what angle does this vertex make for the respective positive x-axis? It's going the same direction as the angle for the previous question right here. The angle for force radians to making the positive x-axis. This is going the same thing, same positive x-axis, and it's following the acceleration is following the positive x-axis, which should be the same thing for question 2, which would be 290, because it's the same thing as following. So this is our displacement formula. How far in meters will the mass move in 5 seconds? So now we use the displacement. However, let's label the stuff that we have. So we already know that it's 5 seconds. That'll be time. Initial volume, velocity will be 0, because there's no velocity that we found. But we did find acceleration, so we put that in mind. Later on we found the velocity. So we put all those three. Let's put them into the equation. 1/2 times 0.92 times 5 seconds square. This will equal us up to 11.5 meters. 11.5 meters. Velocity of blocks after 5 seconds. This will be the next question. Now it's asking the same thing, but it's asking for velocity blocks after 5 seconds. So after 5 seconds, we use the velocity formula. So velocity equals acceleration times. So this will be 0.92 times 5 seconds equals 4.6 meter over seconds. What direction of mass move in t 5 seconds? That is, what angle does the velocity of vertex make when respected to the positive x-axis? There's no change, and to respect to the positive x-axis is following the force apply. It doesn't matter as long there's force apply in its direction. is falling in that direction, which would be 290 degrees. And a x-axis in a counterclockwise direction.